So, getting started with that, I'll start on a slightly lighter note and going back to my education as a chemical engineer. I've forgotten a lot of that though. We were taught Laplace transforms, quantum physics even back then, also coding. I passed Fortran without touching a computer. And, I'll give you two very interesting examples. So this is a premium engineering college, and there's a viva happening for the students, and this is fourth year students, and in the viva, one of the visiting faculties who's from the industry asks one smart guy, so tell me how much carbon is there in carbon steel? So this guy is completely confused. He said it's carbon steel. So he says, sir, about 80%. So he says, you think that much? So he said, no, sir, maybe about 60%. So he said, are you sure? Sir, 50%? So he said, are you sure? Yes, sir, sure. The guy stood up. He says, koila milega, koila. I'm trying to tell you about the disconnect. I joined my job and we were in the plant so I was a youngster and there's another guy who's running around with a bucket. So I said, kahan ja raha hai? So he said, मैं vacuum लेने जा रहा हूँ. I said, what happened? So one of the operators had played a prank on him, saying, बहुत urgency है, थोड़ा वहाँ पे pipe है, vacuum लेके आओ. So these are real life stories. On a lighter note, the kind of disconnects we face, whilst we understood Laplace transformed and scored good marks. And, having said that, many times in the corporate world, we sit and talk about what is academics doing, it is not doing enough, and so on. And I was thinking about it, and I thought, let us just look back. So if you look back at Newton, the laws of mechanics, planetary motion, calculus, just take that out, the whole world goes back 300 years. The internet happened at the Stanford University, electromagnetism, Copenhagen, periodic table, Petersburg, electromagnetic waves happened in another university, the germ theory happened in the University of Berlin, genetics, Mendel, then similarly quantum physics, vaccination, CRISPR, X-ray. So the fact is that when the world changed, a lot of this work has happened in the academia. It's a different matter that it may not be based on next quarter results and therefore we may not be happy. So that is a given. I think the bigger challenge is how can in today's context we do it faster, more effectively, and more importantly in the Indian context what is missing. Some of the people here, I've been made the moderator, I was telling earlier, because I know the least, so I have the job of only asking questions, and some of the people here I have grown up looking up to, and I hope I learn from them today as well. So talking about that, we all know that the future is going to be very interesting. And though you all know it, I believe in the chemical industry as well as everywhere else, we will see a time of absolute radical change, driven by two factors. One, the world saw new materials around the world war, lots of those convenience products, etc. And by the 90s, chemical industry was a sunset industry. Now, you want the same convenience, but sometimes you can't have the same products or the same processes because of the sustainability challenges. There is no choice in the matter. The other thing is how completely new technologies are driving exponential change, not only digital AI, but biotechnology, nanotechnology, biofabrication, and whatnot. And I think India's future, like that of many countries, depends on being able to create knowledge-driven organizations. I think that is part of the gap. We have great IT companies, great crop care companies, great pharma companies, but we think, have we delivered something unique? For example, new actives. For example, a new software that you may be using. So the answer is we've not really done that, And if we have to move to the next level, that's something that also we should be looking at. Otherwise, what happens is what I have seen, say about 40 years ago or 30 years ago when we kind of grew up studying, is, speciality used to be loan and license. तो आप लोन ले लो, लाइसेंस ले लो, लोन एंड लागत, और कुछ लोगों को लगा दो. और आई कॉल दैट द कारखाना माइंडसेट. सो पीपल यूज टू बी कमोडिटी. नॉलेज ले लिया किसी मल्टीनेशनल से और साबुन बनाना स्टार्ट कर दिया. नाउ दैट हैज टू चेंज. दैट इज व्हाई वी आर हैविंग दिस डिस्कशन. And we all realize that this is a big gap, obviously. There's no doubt about it. We keep talking it for a long time. And on one hand, it's a great opportunity. But considering that India is such wonderful talent, and people are recognized throughout the world for being such wonderful talent, the fact that we've not been able to leverage it, and also giving the pressing needs, right from the fact that we are very dependent, right from the fact that we need to deal with the disease burden, the population, the housing, and so many other things. Not being able to do it despite the realization for a long time, I may dare say it's a bit of a tragedy. So I hope in the conversations here, which we will have, we'll get some very nice ideas, and you will as well. I'm sure there are enough examples and learnings which we can have a takeaway from. So my first question, I will start with Dr. Nagaiah, who's the esteemed only academician over here compared to RLs. And so it doesn't matter compared to us. So I was actually reading some of the work that you've done, and you've made some commentary, and you've emphasized that in India, one of the big gaps is, that is where I picked up those carbon steel example from myself, but that prompted me, is that we have a huge gap in terms of the competencies that are required, and that is greatly missing. There's a mismatch. That's the point that you've made several times. And you were also saying that, look, for example, we say that we are great in the pharma industry, but from a value perspective, 6 out of 8 steps are carried out in China. And 80% the ingredients are actually coming from there. So the gap is obvious and the opportunity is obvious. From your perspective, who've commented on it, who's been a thought leader on this process, why do you think is this the case? And I'd like you to comment on what kind of broadly competencies should the institutes and the organizations focus on, and how should the structure and curriculum be broadly adapted to the new ways so that we can leverage the great institutions and the great talent that we have, sir?
Hello, sir. Actually, I am not a fully academician. I am working CSIR IICT in Hyderabad. There are some priorities because I am in the government servant. When this opportunity given for Prashant, then he told, whenever we want a truth, he is asking to me, I am writing the truth for the interest of the country. Coming to the most important, the industry academia collaboration is essential, bridging the gap between the theoretical accept whatever teachers are teaching in the universities, and the practical application, ensuring that the graduate must be prepared with the demand of the industry demand. So for this, the most important who are sitting in the stalwarts in the Indian industrial side, because the involvement, morning Pillai told, the involvement of the industrial people in the board of, that is the university board, is most essential, because your priority is one, the university priorities is one. So when your priorities is that the professors are solving, so we are solving the country problem. That is first point I want to tell. But the better curriculum, research, the industry academic collaboration, skill assignment is most important, because they are only the teaching is the whatever prescribed syllabus of the university, but they are not teaching from the role and responsibility of the teachers and students for industrial projects. This is missing in the curriculum. So and most important, the innovation, because we are spin up. Whenever we are doing anything in the research, whatever the problem has given for the industry, those people are looking from the product and target, what is coming. When you are identifying the side product, you will get the novel things. Whenever you are doing the novel thing, then only their demand will increase. That is most important. For the real world experiment, whatever real world practical experiment is most essential for the nowadays graduates. And the research developments cannot, and most important, many industries are sponsoring project to the universities, institutes in the country. And they are just forgetting from 1 year, 2 year. Those regular interval you have to touch from the institutes and universities, that also is missing, especially from the industrial side. The better curriculum structure in the academic or the strong industry advisory board is necessary. That is most essential for the industry input to curriculum design. This point. And by universities introducing, including the sponsor project must be joint research, because mutual understanding is most important when you are giving any project. You have to tell initially only this is our goal. Goal is important. If you are set goal, and time period also important. Nowadays, every industry where the time is most important for the to catch. Another thing, and the closer relationship between the industry and academic educational institutes can produce graduate better skills for the knowledge of the experience. So this is especially missing. For example, morning Pillais are told only we have the many private universities are there, but the industrial universities there may be 20% or 10%. What my humble request, who are the for the interest of the country, who are the rich in their industry, they have to open from this, take from the Gujarat as a best example. They have the many private universities are there. They are making the skill and they are sending students to all the institute in the country. Because what our honorable Prime Minister is telling, there is a lot of institutes, instrumentations and all they are giving from the central library universities, NITs, NIPERs, and they have the good facilities is there. And the good theoretical knowledge is there. So better to send your student when you are, and one more important thing, whenever you are recruiting any graduates, so barely needed for the 3 to 4 months training from the your industrial application, what you are doing, that also is missing actually. This I want to.
So thank you, Dr. Nagaiah. I move on to our next panelist, Dr. Prashant Puri. When I was he sent me a message. You remember we worked together in ICI. That was many years ago. Not together, he was in the paints business. Of course, he may not remember me, but I do remember him. Sir, you have a very rich background in terms of having studied in the US, which is in the Ohio State University. You've worked for some great MNCs as well as some great Indian companies who have been very successful. And we know, as we spoke, that as far as open innovation is concerned, we are nowhere close to it in terms of what our aspiration is. Having worked in those kind of setups and those kind of organizations, maybe could you throw some light on what works there? Obviously, the US, for example, is known to be an economy driven by invention and discovery. And so how can we make that change to be able to gradually move in that direction? And what is an approach which organizations or institutions can take to start moving on that path?
Good afternoon, everybody. Thanks, Rupu, for this question. This has been a question which I have been actually debating since the time I've come back to India. There are basic differences between the way education, training, and skill development is there in India and abroad. For example, when I was at Ohio State University, I noticed that most of the professors, when they are recruited, have minimum 10 years of industrial experience. They are expert in a specific domain. The funding from the university, the state, and the federal is based on relevant issues and application and have an industrial collaboration angle to it. No research is done which is of really pure academic origin unless they are on that stream of theoretical physics or chemistry. The funding is built on core competency of the professor to build the department's specialization and promote the reputation of the professor or the university to attract students and for industrial collaboration. For example, the department that I was in, chemistry, was known as for its laser Raman spectroscopy. The only institute in whole of US which used and worked, all the professors were specialized in laser Raman spectroscopy. And of course, that led to many other applications of that. The teaching methods are also different between India and US. The teaching methods are project-based with practical rather than theoretical applications. The focus is on a project which is not being done earlier. It has to be new, something novel, so that the student has to do some basic development, understanding what he has done from the theoretical knowledge that he gained in the classroom and how it would be applied. So the project assignment is not based on a test paper or based on, it has to be based on what is interpreted, how you would interpret it and how you would apply it. That's the learning skill. Now, basic difference is students pay for their courses and education in US. They are very clear on what courses they want, what specialized they want to do, and they demand a very learning and understanding skill from the faculty. Each faculty is rated for his knowledge or his ability to impart knowledge to the child. They are very conscious on if I am spending the money, I must get my returns. In India, we don't know what we are going to do. Most of us have certain aspirations and join something else, and we make a success of it. That's the goodness of being an Indian. We know if we are in a different area, we have to be competitive, and there is so much of competition, we have to excel in it. So imagine if you were doing what you wanted always and you liked it. The difference here is everybody who is there, we have IIT graduates who finally, after spending so much of time in education, where do they land up? Where their engineering skills are not needed, in banks. I don't know, engineering skills are required in money counting. Imagine the frustration they have after they reach an age of around 50 or 60 when they realize what they're doing, they don't enjoy anymore. And then they talk about early retirement. I want to do fishing and smoke a cigar and enjoy my life. But they don't enjoy what they did. So it's very important that one must do what really one likes and then enjoy it. A successful model, when I joined the Aditya Birla Group, one of the strategy was how do we improve the Birla Institutes of Technology and Sciences and make them as competitive as the IITs. And what we did was, we had 3 campuses at Goa, Hyderabad, and Pilani. So we personally interviewed all the professors, looked at what was their core competency and what they wanted to do. There were many who had very differences in what they were doing and what they wanted to enjoy doing. So we focused on creating specialization. The Goa campus was on chemicals focus, the Hyderabad was on pharmaceutical focus, and the Pilani was on computer science and electric and electronic engineering. And we shifted most of the professors into these domains so that they could actually interact with the industry and enjoy what they did. And today, I must say, because I am also was in the scholarship evaluation in the Aditya Birla Group, and we used to have 20 scholarships to be provided for IIT students as well as the other BITS Pilani students. So out of 100 applications from each institute, we used to narrow down to 20. And can you imagine, over the years, the shift was that the BITS Pilani team would take away nearly 80% of the scholarship. That's because there were certain changes in that. The professors were enjoying what they were doing, and they were teaching that skillfully for the students too. We also made it mandatory that in the institute, that the student would actually, during his coursework, spend at least 6 months in industry. He would get the experience and really utilize it. So the funding for the professors in BITS Pilani was based on collaborative projects, nationally and internationally. So focus on innovative solutions that are commercially viable and can be deployed with either the existing industrial infrastructure, unless it is a breakthrough technology or revolutionary where the business house is going to make a lot of profit. I think what happens in India is when you sponsor a research to a university or institute, you do get a solution, but it's not commercially viable. And that's the important part when you said so, that we need to have an engagement with the industry and the institutes at a very periodic and fundamental level to make it clear that we want a solution which is industrially applicable and can be applied for commercial success. When we talk of commercial success, I found most of the institutes in India have no understanding. And I think it is really necessary for the industry, before you sponsor a work, to have a frank chat with the professor or the institute on what is a commercial viable solution. I think that once that bridge is obtained, I think you find a solution which is more practical and more applicable. I hope that takes care of the answer you wanted.
Very, very focused and some very good points. I wonder why all of that doesn't happen, and also good, encouraging to see that at least at some level this is happening. On a different note, I think ChatGPT is a conspiracy against India. Because you were talking about novel projects. I'm sure our people will get the novel project reports also out of ChatGPT. You know, our children in schools are already doing it. So, moving on to Dr. Fondekar, and you have a similar rich experience in research in India and abroad, having worked in India and abroad, and you bring a very broad perspective. You know, they say that innovation is a multi-stage process. There are several stages to it, and it cannot be just looked at as one whole. And so maybe if you can deconstruct it into several stages, and that can provide us some insights and as to how this engagement with the academia can be made more effective.
Yeah, thank you very much. Yeah, this is a very interesting point, because if you really look at a product, right, or a product life cycle, it right away starts from the innovation, then you have a developmental phase, then you have a launch phase, then you have growth phase, then the product reaches the maturity, right? And finally, it declines and the product is out. So it's important for us to focus at the right areas, right? Very clearly, from the innovation or development phase till the maturity phase, what is very important is the time. Time is a key factor for us. Whereas it reaches from maturity to decline, the cost plays extremely important, right? Now, if I consider an example of agrochemical, a new molecule in agrochemicals, typically simple chemistries are over. Now it's a lot more of a complex chemistries, fantastic mode of actions. The question is, do you really want to do everything by yourself, right? Or can you really work with academia, because they have a different expertise. They work with the structure activity relationships, they can work on the computational science, and can you really collaborate with them? Can you bring that time faster to the market? The new product, can you bring it to the faster? Because what was realized, if you delay your launch by 6 months, you literally lose 50% of your revenue. And if you overspend by 50%, you only lose 3% of your revenue. That's what the data says. So this means the time to the market is key. And very clearly, in industry, we should realize we can't do everything by ourselves. And that for collaboration with academia is absolutely important. Now, when we go from the innovation, that the lead molecule, then we go to the growth, and once it reaches the maturity, now the product is stabilized. But that our efforts are not over, because we have to do the continuous improvement programs, right? Because there are competition coming in, and therefore the big problem is the Chinese, right? That's what we all talked about in the morning. And therefore you focus on, can you really backward integrate? Can we really, how can we really get a much better quality of the products? And once it reaches the maturity, you are worried about the, most likely the patent is going to expire. How are you going to protect your molecule? Idea is how can you extend, elongate the life of the molecule, right? And therefore, important part is every stage you need to can collaborate with academia, work with them, whether it's a quality issues, whether it's a backward integration, or during the development at every phase, right? Because as an industry, we can't do everything by ourselves. And this is an extremely important factor, part of the innovation, which can really help us to take this forward.
Thank you, sir. It's a very valid point. Not only can the industry not do everything, but I learned from it, the academia cannot do everything. So it is good to pick elements of it and use the expertise. That's a very interesting thought. Thank you for that. And we'll move to Ankit, who brings a completely different perspective, who has a background in IT and digital transformation, to doing very exciting things, sitting next to Dr. Puri, molecular modeling, scientific computation, and amongst other things, he's an author for children's books. And you know, future predictors or those gurus say that in a couple of decades we'll reach a point of singularity with explosive growth in technology, and technology will take over. Because then we'll not need this panel discussion. But till then, you know, can you use your skills of storytelling to children, given that this world is digital world particularly is a little difficult to understand. How can we use this digital technology and some of the emerging tools to bridge this gap? Obviously, it's about connecting need and capability, but I imagine that it is not unidimensionally connecting need to capability. And I think what digital tools can do is make it multi-dimensional in terms of multi-needs, multi-capabilities being brought together to provide a solution, which was in times before possibly not possible. I do not know whether I'm imagining, but I would like to hear from you.
Sure. Thanks for the question. I think I'll also pick up what Dr. Fondekar said, and I'll take it forward from there. I represent an organization, probably the only agrochemical company in India, which is working in discovery. So we are working into identifying new novel molecules, and PI would be the first agrochemical organization in India to discover a molecule, develop a molecule, and deliver it to the world. So and that is coming up. And if I give this motivation to all the other agrochemical organizations, I think that's where digital and molecular modeling and other future technologies play a role. If any agrochemical organization in the previous, a decade back, thought about investing into discovery, right, they would talk about big investments, right? There's a funnel, as Dr. Fondekar said, from innovation to development. So if you synthesize 1 million molecules, then probably the probability of success would be 1 out of those millions. And that is where digital comes into picture. In my last 8 years at PI, we've invested into molecular modeling simulations, which helps us to design maybe better. So, our hit rate is maybe out of 30,000 molecules, we've got a lead molecule already, and we have other 2 in pipeline. So, the modeling is the first phase. Of course, my modelers don't come from an outer space, they come from academia. I have 40% team which comes from NIPA Mohali, IIC, Kolkata, and so on. And but the gap is the postdoc opportunities. Most of my team members, though they study in India from the PhD perspective, but they go out abroad to do postdocs, right? So that is the first phase of digital technology where molecular modeling simulations can help in the design phase of the innovation. Then after design comes the make phases, right? Of course, what do you make? I mean, if I talk about academia, when they do research, they do an endless research. They keep on synthesizing a molecule till they find an activity, right? That is where I see a gap between academic researchers and industrial researchers. There need to be an end time, right? When do you deliver, how do you deliver, and how fast do you deliver an active molecule? And that is where the other aspect of digital technologies comes into picture, which is called machine learning, right? Now we have enough data. Of course, we don't have data as comparable to the likes of Syngenta, Bayer, BASF, but then we have a research data for last 8 years. And we do have some market data with respect to these molecules from the literature databases as well. So we build machine learning algorithms which tells us what is the probability of a molecule to show activity in vitro, in vivo, right? And also what could be the toxicity levels of those molecules, right? Whether it is in terms of mutagenicity, ecotoxicity, and so on, right? We're not like a pharma world. Typical from a design of a molecule to a launch of a molecule, it covers close to 120 to 150 test trials. In the pharma world, it is animal trials and human trials because it is consumed by humans. Whereas in a agrochemical world, the chemical which you apply, it impacts your soil, it impacts your environment, it impacts the cattle or the animal which eats that, it impacts the human. So the number of trials are more. So it is always better to fail faster, right? So that your investments are saved, your research is faster, and then as Dr. Fondekar mentioned, so launch to the market fastest will be the goal, right? So, if you see from a discovery phase perspective, how do you design your molecules? What molecules do you make so that you get best results? How best can you test those molecules in the fields? We work in agrochemical space again. So, of course, a lot of tox trials, field trials needs to be done across the globe, right? And that is where you need to collaborate. So in India, you can't have a field across the country, but there are a lot of agricultural institutes which are covered across the states. So you need to probably collaborate with them to get those field trial results in. And what kind of weather impact, what could be the soil impact on those things, we do that. And then comes the later aspects of from innovation when you need to probably pre-develop a molecule, develop a molecule. That's where, the likes of digital twins, process modeling, process simulations, and all those have an impact. So if you see, digital in today's time, not only from the later stages where all my speakers have spoken about since morning, but also maybe in the early phases of discovery is where we've seen an impact now.
Thank you, Ankit. It was so nice to hear a digital IT guy talk about molecular modeling, in vitro, in vivo, and few other things. So it's, you can see the convergence is very beautifully happening. So very, very good to see that. And I move to our next speaker, a veteran, very experienced, Mr. Anjani Prasad. Sir, you've worked for several great companies, starting with Sandoz, Clariant, and many others. You've also worked in many geographies. You are part of several industry associations. I think industry associations are one platform of convergence between academia and industry. So given that, whilst this has been an old story about how to leverage academia, from your experience, why do organizations like these struggle, particularly in India? And what are your thoughts on overcoming, and particularly whether these places of convergence like associations can be used as an enabling mechanism?
Yeah, I'm audible now. Huh? Thank you. So I was in Coimbatore yesterday, and I was to be in the first session, but then thanks for accommodating here. Listening to all this, let me make it a bit lighter. Then I come to my experience and what I can contribute. How many of you have seen this movie which has just been released 2 months back, Shrikant Bhola? And you see this is a very good example of a blind person who is not allowed even admission in our institutes. Please go and see this. Eventually he got an admission in MIT. When he came back, there was no industry to help him out. And that's the main problem which you see. And who funded him? When you see the movie, you'll see that it was President Abdul Kalam who funded him to start a project. Now, that's the pity side of the link between academia and the industry. Okay, so we have our rules in the academy. Poor people are not able to get education. They have the best of knowledge. And what I tell the industry, please use your CSR funds. That's going to help. I visit a lot of labs around and the colleges. And they call me. When I see the lab, it's a very sad story. You can't develop anything in that. I can tell you that. The best of the labs. They require a lot of funds. We have people, but we don't have the infrastructure. We don't have the money to run the institutes. They're running on gas, I can tell you that. There are many things can be developed. As far as the needs of India is concerned, I can tell you that. We're talking all big stories, but I go to the grassroots level. Take the simplest of example. What we play the maximum in sports is cricket. Is it not? And then I got a T-shirt. I wanted to watch this, World Cup match at Wankhede. I got it at Adidas at 5,000 rupees. And when I wore it, it was more comfortable than any other T-shirt. But unfortunately, even the fiber, you can't get it here. The technology to make it, you can't get it here. I was talking to the activewear manufacturers or the key people from Taiwan, a small country, has so much of knowledge that they can give the chips of the world, the highest technology, even in the area where we feel that we are strong, like textiles, we are far behind in terms of knowledge. And I say there has to be a big collaborative efforts in the two institutes of different countries. We're talking about joint ventures in the industry. Where are the joint ventures in the institutes? And most of the institutes are run by the politician. So how do you get the quality? That's another part of it. You spoke to me about the whole, set of various forums which I am in. And I can tell you that most of the forums, it's only industry to this forums which is belong to, and they take it to the government of India. Tomorrow I am with the textile minister. He's called for understanding what we can do here. Now, what these people do, all these associations around, they go to the joint secretaries and the secretaries who have 10 years, not more than 3 years. And they're given the 10 years at the time of their retirement. And they have no time to take it further. How can you build it up? Now, when you look at the technologies of the world, I was there in Germany, in Berlin, and I saw the 3D printing 15 years back. Okay? With fashion, apparel made out of 3D printing. Now the world of China has gone and made tissue printing. They're printing organs. We don't have one big innovation center even for 3D printing, which can be the most future. I mean, when you look at the hyper curve of the innovation, 5 years back, it was online translation. Now in ChatGPT, you can get everything online, 221 languages. And it can type and give it to you in the language which you want. So those things have gone. But in our education system, how many of these things are taught? When I visited, I was also in the global role of global head of innovation, for example. Open innovation is a big topic which you raised. Open innovation, there are hundreds of institutes around the world, and R&D takes longer gestation time. Success factor is also plus or minus, maybe small, but open innovation to scale up is too good. I went to IIT Delhi. I don't want to name the professor. He had developed a new technology. I said, I want it. I got a machine guy also who can scale it up. Then he said, my student has left. I lost the knowledge. I went to IIT Mumbai in chemical engineering department. 1,500 patents are lying in the drawers and carrying rust. I feel a lot of change we need to do in this whole story. I was talking to the Joint Secretary of Chemicals and also the Joint Secretary of the Textiles, even the Secretary. Even to Piyush Goyal I mentioned that day in the forum, in the big Bharatex. I said, we need an innovation portal here, which can connect the industry to buy, the students to make research and make money out of the royalties, the institutes to earn out of this royalty. It's a big business model. If Switzerland can produce 2 times more patents than whole of India, we don't have even the patent good lawyers to protect against the patents. You have to go to Germany. For my own patent, which I did, I wanted to do it here. No way I could do it. I had to go to German lawyers. They know how to manage. Even the trademark registration is becoming a problem. There are many things I can talk. Hope I have time. 3 minutes is left. I'll leave it to the other speakers. These were some of my thoughts. Thank you very much.
Thank you, sir. Thank you for showing us the mirror, but we all are responsible. And you talked about the movie and some other things. वो थोड़ा हमारा colonial mindset तो है ही. अब हल्दी का patent US से होगा तो हम खाना start कर देंगे. That is true for a lot of knowledge, a lot of work that does get done in India. And last but not the least, as in a relay race, you know, the good ones come in the end. So Deepak, you bring a perspective which is running manufacturing, operations, supply chain, business, multiple industries. From a manufacturing technology perspective, usually whenever I've attended such meetings, a lot of focus is around chemistry, molecules. But there is a lot of meat around technology, processes, supply chain, business processes. I may be wrong, where the gap is even bigger because we don't even think about it. So from your perspective, what are some pressing areas where in that area where we should start thinking about?
Uri Baba, ki bolbo. So you said that you will leave it to other speakers. I realize I'm the only speaker. So plural has become a singular. But before I go on, I want to take this opportunity. I was very happy to see Dr. Mehta today morning. It brought back memories. Dr. Mehta was my first guru. So before I start, I would say thank you, Doctor, for being my first teacher. The disadvantage of being the last speaker is that whatever I had thought of I'll speak, everybody has already spoken. So I don't know what to speak. The advantage is it has cleared my thoughts, what to say, what not to say. So I'll try, and I realize I have very little time left, so I'll try to be very crisp. Everything that has been said is what I totally agree with. But let's look at some of the numbers. So I was reading an article a couple of months back. Let's look at the spend as a percent of GDP that each country spends. South Korea is somewhere around 3.5%. Japan is somewhere close to 3.5%. USA is about 3% of their GDP. China is 2%. And we always said China is purely manufacturing, but China is spending close to 2% of their GDP. India is less than 1%, maybe 0.7, 0.6%. Now, if you go back 20 years 30 years in history, maybe China was at the same point of inflection that India is today, which was purely China as a country was providing only cheap labor and therefore the cheap cost of production, which probably India is thinking right now that if I have to be a manufacturing hub, this is what I will do. But I think in the long run, it will not be sustainable. And if you're looking at, the topic is transforming India into a global manufacturing hub, somewhere at some point of time, we have to start thinking of innovation. Other statistics which I looked at, many US companies and companies which are primarily in the war industry, Tomahawks, Lockheed Martin, for them, the manufacturing of the main components are done in China. There are more than 2,000 companies in China which are supplying the essential parts for manufacturing of these, defense sector components for USA. Why China has been able to do it? Clearly, when I marry the two data, which is about the spend on the R&D vis-a-vis focusing on manufacturing, I think that's where something will happen. Coming back to an industry perspective, if I say it is 0.6% or 0.7% of what India is spending on the GDP, I am a management guy. So typically we talk of whatever you might say like future dekhenge, but abhi to business chalna chahiye, which is about business as usual. We call it BAO, that's the term that we use. My perspective on this is, if India has to become a global manufacturing hub, the industry has to bite the bullet and say, okay, business has to happen, so I'll commit some money to the business as usual, but I have to look at future also. The businesses have to perpetuate. India has to become a global manufacturing giant. For that to happen, industry has to commit, let's say 1% of their budget, or you can say NSR or revenues. So like you said, it could be part of the CSR activity as well. Once that money is, so that's where the industry has to bite the bullet and say, okay, I'm committing this money. After having committed the money, what does the industry and the academia? I hope I got this pronunciation right, Rupark. You were struggling. I am also struggling with the same pronunciation. Somewhere, this is where the industry and the academia has to come together and say, okay, now we have these funds coming in by means of CSR, or let's say companies are committing 1% of the total revenue to innovation. What can we do together? Everything else that has been spoken over here, whether it is building the skill set, whether it is talking of, creating programs which are aligned to industry. So it is not just Laplace transform, as you rightly said. Even I don't remember. I in fact forgot about it. You reminded me. So what is it that so how can the industry restructure their? How can the academia restructure their curriculum, which is more aligned to what the industry wants? And I can give you a very specific example. This is something that I personally am very proud of having done in my previous organization. When I was in PCBL, we collaborated with a university, UPES in Dehradun. And what we did, we created an elective in the 4th year on carbon black technology. And when that elective happened, so this is a MOU we signed with the university, our management staff used to go and teach in that university. And that elective had credit of 4. So what we did, we worked backwards. So we used to go and take the third year students as a summer trainees. Those students will come, we used to interview them, they used to come, and we used to give them very specific project. Once we have given a very specific project, and then we, depending on how students have performed, we used to offer the PPOs. Once we have offered the PPOs, the condition was, you have to go back and take that elective. And that brought in a lot of coordination that happened between UPES in Dehradun and PCBL, which was the company where I was working in. And we have been running this program for last 8-9 years. And today, if you look at it, most of the middle management at the production manager or senior production manager are the guys who have come through that process. So that's something that's like skilling the people is what probably can happen. Couple of things which actually do not get as highlighted, maybe policy advocacy with the government. Today, if you look at it, industries are not as equipped to interact with the government. They may not have as much data, they may not have as much information. Maybe the industry and academia can come together and work towards on policy advocacy. How do you go and talk to the government and help government draft policies which is more aligned to turning India into a global manufacturing hub? These are a couple of things which comes to my mind. I'm sure I think everybody has spoken very passionately about it, and everybody has spoken all the right things. These would be my inputs.
Thank you, Deepak. I can say, having attended many sessions, that if you nicely summarize what everybody said, there is a very nice compilation of very practical and good suggestions. You know, Praveen, maybe you can look at it. I thought that it was very practical, very good, and a very wide spectrum. You know, new things that you covered, policy, etc., were not talked about. You know, I also have to look like a moderator, so I'll say 2 or 3 things in the end. And, you know, I believe one of the things which I have kind of grappled with is a realization that competitive advantage comes at 3 levels. One is know-how. That's easy now. You can get scientists, you can get ChatGPT, and so many other things. Then is systems and processes, we are getting better at that. That is level 2, which is more difficult to copy. Know-how is relatively easy. Level 3 is culture. I think that gives a competitive advantage which is nearly impossible to overcome. You know, we think suddenly we'll overtake Europe. That's not easy. Those people are working on things ahead. So that's also something that we need to look at. And we all said that, look, we need to do something rather than only talk about. So I'm going to end with a nice slok from the Bhagavad Gita, which says, I don't remember it, so I'll read it out. Udyamen hi siddhyanti karyani na manorathe, na hi suptasya sisya pravishanti mukhe mriga. Udyamen. Basically saying that eventually purusharth, effort, will lead us to obtaining something, because a deer will not come and get into the mouth of a lion. And in order to do that, a lion tries, fails, gets injured so many times. So there is no shortcut. It will not happen because the pride once sat in a panel and told him how to get the mrig in his mouth. So like I heard one yoga guru say in 3 words, karne se hoga. So with that, on behalf of the panel, I would thank you for listening to us. I enjoyed learning from such people. I am not going to try and summarize. You don't try and summarize the gurus. It's learning for me. Thank you very much for your patience, and hopefully, despite being an after lunch session, at least some of you could absorb some of it.